Well, let us talk about diminishing marginal productivity. Okay, say you have land, okay, and you have labor. Clear? And of course, these two units inputs, they produce some output. Okay, say you have 1 unit of land. On this, you started producing 1 unit of labor, and this has given you, say, 3 units of output. You still have 1 unit of land, you increase labor to 3, and this has started giving you, say, 6 units of output. You still have this unit of land is big enough, and you still have 1 unit of land. You increase the output to labor to 7 units, and output has increased to, say, 10. Okay, you increase the output to, say, 13 units. Okay, sorry, labor to 13 units. You have just 1 unit of land. Output increased to just 12. Fine. So what is happening? In case if we look at it, when there was 2 units of addition of labor to the first unit, output increased by 3 units. Okay, then there were 4 units of labor which were added, output increased to 4 units. Okay, and then you have 6 units of labor which are added, output increased to 2 units. Okay, so your productivity is falling. Your marginal productivity is falling. Okay, well, in this case, if you look at it, 1 unit of labor was giving you 3. Okay, so here this addition of 2 units, it is actually giving you just 1.5 additional output per unit of labor. Okay, here there are 4 units, so they are just giving it 1. I'm sorry. Okay, here there are 6 units. Okay, so it is just giving the addition of 0.3. You getting the point? See, in case if this would have been like 1, 2, 3, and 4, it would have been like this. This additional unit of labor would like this. This is one scenario, 1, 2, 3, 4, and your output is the same, 3, 6, 10, 12. In this case, your marginal productivity of labor would have been, in this case, nothing. In this case, it would have been 3, it would have been 4, it would have been 2. So here, each additional unit of labor, okay, is adding this much. Okay, so in the first case, it has added 3 units. When labor is being added, one more unit of labor is being added, so it increased the output to 4. When 1 more unit of labor is added, it increased the output to 2. Okay, by 2. Okay, but here, in case if you look at it, okay, let me just write it again for you guys. Here, labor is being not added by just one unit. Okay, here, say labor is like this: 1, 3, 7, and 13. It is like this. Okay, and output is 3, 6, 10, and 12. Okay, so here 1 unit of labor is giving you 3 units of output. Now there is an addition of 2 units. Fine, and these all 3 units together, they are giving 6 units of output. Okay, so, and this additional is 3. Okay, 6 minus 3 is just additional is 3. So this additional 3 is distributed among this additional 2 units of labor. So 1 unit of labor is actually giving you just 1.5 unit of output increase. Okay, in this case, it is an additional 4 unit of labor and 4 unit of output, and here additional 4 units of labor. So these additional 4 units of labor are giving additional 4 units of output. So 1 unit of output is just giving additional 1 unit of 1 unit of labor is just giving 1 unit of output. Here output has increased by +2, okay, but number of labor has increased by 6, okay. So this additional 2 units of output is distributed among additional 6 units of labor. So these additional 6 units are just adding like this, okay, almost like this, okay, just 1/3, clear, approximately. So what you are trying to say is that when this other input is fixed, so these additional unit of labor, okay, the additions which these additional unit of labor they make to output, it keeps on falling. This addition is falling. Okay, these additions is falling. Okay, all of these additional unit of labor. You getting the point? These additions, once they have started increasing, okay, and then they have started falling. It will not fall from just the first unit, but they may start increasing and then they will fall. Okay, so it is like this. Clear? So what will happen is initially that additional unit of labor might add more to output, but then it will start falling. Okay, so this is your diminishing marginal productivity. One more thing which you have to understand in this is, I mean, just for the sake of completeness, that your second partial derivative would be less than 0. Okay, you have the production function Q. Okay, you differentiate that production function with respect to the input, say labor, you get your MPL. Okay, and in general, if you differentiate this MPL again with respect to labor, okay, say you get, which is del 2Q by del L2, which is FLL, this would be less than 0. Similarly for capital, this is MPK, this is del of MPK by del K, which is del 2Q by del K2, which is FKK, which is less than 0. Okay, so now you also have to understand is that changes in the marginal productivity of labor, it also depends upon the changes in the other input also. Okay, so okay, say land or capital or anything. Okay, so you also have to be concerned about the cross partial derivative, which is FLK. In general, it is assumed to be positive. Okay, so in general, it is assumed to be positive. That is cross partial derivative is greater than 0. Okay, but the point which we have to prove here is that marginal productivity, it falls as you go on increasing the amount of input. Okay.